This video we are going to talk about units of measurement, specifically a SI system, and then we're going to figure out how to convert between the metric units. That's called dimensional analysis, so we'll intro into dimensional analysis by the end of the video. So the SI system of measurements, it's based on the powers of 10, which makes it so much easier to use. I know in science you see it like once a year, you talk about metric, you learn how to convert, and then you move on. But trust me, I've lived in a country where they use the metric system, and I just find once you get used to it, it is significantly easier to use. Now, easy conversion between units, that's one of the reasons why it's better. And everyone else in the world agrees on it. If you go anywhere else, almost anywhere else in the world, you will see street signs in kilometers per hour. You will get the temperature in Celsius, and it just makes it harder to convert. And you can look up the mistakes that have been made in the conversion of metric to the U.S. system of measurements that the U.S. uses. Like the satellite that I think it was Mars that it crashed onto because they forgot to convert like Newton uh, meters to pounds or something like that. So we just use the metric system in science. Everyone does, and it makes it easier. So a standard is a physical quantity used to compare with. So for example, there used to be a chunk of metal that was deemed to be 1 meter long, held in a vault, and every other meter stick that was ever created was at some point calibrated against that original meter, that chunk of metal that was deemed to be 1 meter. Same thing with the kilogram. You can see here you've got a chunk of metal. This was considered 1 kilogram. The problem is that even though it was sealed under just really great conditions so that it would never react, it still managed to react or gain some dust, something, and corrosion of some sort, and it started to slightly gain mass. Now, it wasn't a lot, it was a tiny, tiny amount, but if the original thing that you considered a kilogram changes, it really messes with a lot of other science values out there. So actually just in the last year or so, and depending how old this video is when you watch it, this is 2020, um, the kilogram just got the actual kilogram metal. This became outdated. They have refigured a way to have a kilogram standard without actually having a physical object. It was the last unit that required a physical object to represent the standard kilogram. Um, so we'll talk about some of those other ones in class, like the second is defined by the number of oscillations between like the hyperfine state of a cesium atom. Uh, and then the meter is now defined by the distance light travels in a vacuum in like 0.000 some odd seconds. So there's no actual chunk of metal anymore. We can just measure the time it takes light to go, or how far light goes in a certain time period, and that is a meter. There are 7 SI units based for all measurements, so I'll show you these in a second, and you need to know them for the test. There you go, I even said must know for tests, look at that. Derived units. Whenever you combine some of the fundamental units, you come up with a derived unit. So if you remember from physical science or earlier, velocity equals distance divided by time. If you go 10 meters in 2 seconds, you do the math on the numbers here, and you get 5. But you also have to do the math to the units. You get 5 meters divided by seconds, or meters per second. This is a derived unit. You had to apply math to create that unit. It's not one of the fundamental units. The prefixes are a base 10 system. They're easy to convert, and you must learn them. You'll get a pink sheet that you get to use, so like kilo, centi, milli, etc. Now, a couple other things. Mass versus weight. This is kind of odd in here, but we got to cover it, so it's got to go somewhere. Mass is how much matter is in something. How many atoms is it made of? Weight is the force of gravity pulling on that mass. They are different. They're not the same thing, and you do need to know this for the test. So the example I use is if I weigh 90 kilograms, that means I have 90 kilograms worth of matter inside of me. Now I weigh about 200 pounds. That is a force. That's the gravity pulling down on me. Those two measurements are not the same thing. If I were to travel to the moon, I would still have a mass of about 90 kilograms. But my weight would no longer be 200 pounds, it would be much, much less. So the amount of matter inside of me does not change when I travel to the moon, but the force of gravity that's pulling down on me definitely does. So weight is affected by gravity, mass is not affected by gravity. So an example is Weight Watchers versus Mass Watchers. If I'm trying to lose weight, I could do that real easy if I had a spaceship and I flew to the moon and suddenly I'd weigh 6 times less. But if I really truly want to become healthier, I actually want to lose mass. I want to get rid of some of that matter that is inside of me, some of that fat that maybe is not as healthy for me to hold on to. This is your pink sheet. Here are your 7 fundamental units. Now notice you got meter, kilogram, second, ampere, Kelvin, mole, candela. This one always gets people. The fundamental unit for mass is actually kilogram. It's not gram. So always keep that in mind. If you want to know why, I can tell you in class. I can explain that. But the video, to keep it short, I'll do that later. Now here's some of your derived units like square meters, meters squared, density, energy. You can look up those on your pink sheet when you get it. The prefixes, here's a list of all your prefixes. So you got your base units. These are without a prefix, so like the meter. A meter, you know how long a meter stick is. Now if you want to divide that meter stick into 1,000 equal pieces, the length of that thousandth of a meter is equal to 1 millimeter. So millimeter is 1/1000th of a meter. So there's 1,000 millimeters in 1 meter. Now the key to this pink sheet is that these prefixes are all relative to the base. So deci, centi, they're all relative to this base unit. So if I need to convert from kilo to deca, this sheet does not tell me how many decameters are in a kilometer. What it does, if I need to go from kilo to deca, I could go from kilo to meter, and then meter back to deca. So you always have to go through the base unit because all these numbers are relative to the base. They're not relative to each other. This does not tell me how to go from here to here. So just keep that in mind. And then down here you got your metric unit and then your, I guess, US version of all the units. Okay, dimensional analysis. This is a way of converting units using algebra. It's pretty easy once you get the pattern down. So follow along and practice, 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 practice. So we use the ladder technique. And then the conversion factors are ratios derived from units, and they always have to be equal to each other. So you'll see what we mean in a second on that. Write this down on your pink sheet, that the prefix equals 1 and the base equals the number. Write it down on your pink sheet, preferably on this side. I don't know if you can hear my son's trying to get into the room as I make this video and he's throwing a fit, so I apologize if you hear him crying. Let's see here. Sorry, I got distracted. Examples. If we need to convert 234 kilometers to meters. So what I need to do here is go from this unit to this unit. Now to do this, I start a ladder. Now whenever I start a ladder, I always put this number, the first number, 234 kilometers, in the top right box. From there, I take whatever unit is here, and I move it down. So I'm going to put km because km is my unit. I move it down. Now, this is just kind of the first step. This is like where you hold your first number. Now, the second spot is where my conversion factor will go. I need to go to meter, and this is a base unit, so I can go right to it. I can go right to the meter because it's a base. Now, from here, I need to figure out what my conversion factor is. I need to know how many kilometers are in a meter or how many meters are in a kilometer. So if we go back, remember that the base gets the number and the prefix gets the 1. So we're actually going to go back here. The prefix, what we mean by prefix, meter is the base unit, kilometer, kilo is the prefix. So this is the one that has the prefix. This is the base. So the one with the prefix, the extra letter, gets the 1. The base gets the number. Now what number does it get? That's where we go back to our pink sheet and we look up kilo. Kilo, go across, kilo equals 1,000. Kilo equals 1,000. So that's the number that the base gets. So this is where you're going to write prefix equals 1, base equals the number. Now the prefix gets the 1, but the prefix is what you look up to tell you what the base gets in your conversion. I know it's a little confusing at first. Let's go back. So the prefix gets the 1, but the base gets the number. And kilo equals 1,000, so that's the number that the base unit gets. Now, once I'm done here, you multiply across the bottom, and you divide across, multiply across the top, divide across the bottom. Now, dividing by 1 doesn't do anything, so if I were typing this into my calculator, I'd do 234 times 1,000. That equals 234,000. And that's the same number of sig figs. Now, kilometers times meters divided by kilometers. So if I do this, you got to do this math to your units as well. Kilometers times meters divided by kilometers. My kilometers cancels out and I'm left with meters. So this is my final answer and I box it in. So whenever you have a unit on top and bottom, you can cross it out because they cancel. See if we can squeeze one more in before the time runs out. I wanted to get 2 in, and I always do them under 15 minutes. So again, I set up a ladder. Trick here though is that this is not a base unit and this isn't either. My base unit is seconds, so I have to go to seconds first before I go down to here. And I'm going to do this a little bit quicker because I have to get this done in a minute and a half. So I put my first number right here, milliseconds, but I can't go directly to hectoseconds. So I'm going to bring I'm jumping ahead here. I take this unit down, milliseconds, and I can't go directly to hectoseconds on top. I have to go to the base first. Because remember, the prefix gets the 1, the base gets the number. Now, the next thing is I take whatever unit is on the top right, I bring it down because I eventually need it to cancel out. Now I can go from the base to wherever I want. Prefix gets the 1, the base will get the number. Now for this one, I need to look up milli. If you look up milli on your sheet, it equals 0.001. If you look up hecto, it equals 100. So what you're going to do is your milliseconds crosses out, seconds crosses out, you're left with hectoseconds. You do this times this divided by this. And 1,000 times 1,000th is 1 divided by 100 is 0.01 hectoseconds. So that's what you should get in your calculator if you calculate this out. And again, all your units, millisecond, millisecond, seconds, seconds cancels out and you're left with hectoseconds. So that's how you do a 2-step. If you end up with 2 prefixes, you have to make it a 2-step. If you have a base in there, you can always make it 1-step. That's where we'll end for this video.